Here is a circuit where EMF of 6 volt is applied here. A resistance R1 is of 4 ohm, R2 is of 5 ohm, R3 is of 10 ohm, and R4 is of 5 ohm. So first of all we have to find the equivalent resistance, and secondly current through each resistor, and current through each resistor. So we have to find this. So first of all we see here this R2, R3 and R4. This point, this point, this point, this point, they are all one and the same point. Similarly, this point, they are all the same point. So this R1, R2, R3, R4, all are in parallel. Therefore, 1 by Rp will be equal to 1 by R2 plus 1 by R3 plus 1 by R4. That means 1 by 5 plus 1 by 10 plus 1 by 5. That is, LCM will be 10. This will be 2 plus 1 plus 2. That is 5 by 10. So R parallel will be equals to 2 ohm. And now the equivalent circuit becomes 6 volt. So this is 4 ohm and this is 2 ohm and this is finally. So this way, here we get this R parallel and R1. This R1 and R parallel are in series. Therefore, are in series. Therefore, R equivalent will be equals to R1 plus R parallel, that is equal to 4 plus 2, that is 6 ohm. Now the final circuit becomes 6 ohm and 6 volt. So this I, therefore I equals to V by R, that is 6 by 6, that is equal to 1 ampere. So here is the 1 ampere. Therefore, I1 equals to 1 ampere. Now the potential difference across, suppose I say this is point A and this is point B. So VAB will be equals to this E minus I into R1. Whatever voltage is here plus this voltage will be equal to net voltage. So that means it will be 6 minus IR1, that is equal to 6 minus 1 into 4, that is 6 minus 4, that is equal to 2 volt. Now I1 will be equals to VAB divided by 5, that is 2 by 5, that is 0.4 ampere. I2 will be equals to 2 by 10, that is equal to 0.2 ampere. And I3 will again become 2 by 5, that is 0.4 ampere. Just once again, we have to find the equivalent. This is the circuit given to us. Then we have to find the equivalent resistance and the current through each resistor. So equivalent resistance for equivalent, these points are same. All points are same. So that means they are connected here and they are also connected over here. So all R2, R3 and R4 are in parallel. Therefore, the 1 by R parallel is equal to 1 by R2 plus 1 by R3 plus 1 by R4. That is 1 by 5 plus 1 by 10 plus 1 by 5. That is LCM is 10. Then 2 plus 1 plus 2, that is 5 by 10. That is equal to 1 by 2. So R parallel is equal to 2 ohm. And now the equivalent circuit will become this and this. So these two points, this R1 and R parallel are in series. So R1 and R parallel are in series. Therefore, the R equivalent will become R1 plus RP, that is 4 plus 2, that is so on. Now the final circuit will become like this. So I will be equals to V by R. So V is here 6 and R is again 6. So that is 6 by 6, that is 1 ampere. Now we have to find the current through R1. So whatever current is passing through this is the same as through R1. So I1 will equal to 1 ampere. So that is I equal to 1 ampere. Here I is equal to 1 ampere. Now current through R2, R3, R4, for that we need the potential difference across here. So since they all are in parallel, so the potential difference across them will be same. So let us say that is VAB, A and B here, and then plus this V1 will be equals to the net voltage 6. So here VAB will be equal to E minus IR1. So that is 6 minus IR1, that is 6 minus 1 into 4, that is 6 minus 4, that is 2 volt. So now current I1 will become VAB divided by 5, this R2 resistance, that is 2 by 5, that is 0.4 ampere. Similarly for that, this will be 2 divided by 10, that is 0.2 ampere. And then for this I3, this V divided by 5, that is 2 by 5, that is 0.5 ampere. So the current through R1 is 1 ampere, R2 is 0.4 ampere, R3 is 0.2 ampere, and R4 is 0.4 ampere. And if you find Kirchhoff's law, if you apply Kirchhoff's law here, so this will be I will be equal to I1 plus I2 plus I3. And this I1 plus I2 plus I3, just see, plus 0.4 plus 0.2 plus 0.4, that will become to 1, and that is there. So this way you can check your answer also. A charge Q equals to 2 millicoulomb moves in uniform electric field E along the path OABC in the given figure. Coordinates of the points are O 0 0 0, A 1 minus 1 0, B 2 0 0, C 1 1 0. The value of E in the figure is given as it is uniform electric field directed towards the x direction, x-axis, positive direction of x-axis, and 10 raised to power 4 Newton per Coulomb. So find first part, state the plane of motion of the charge. Second part, calculate the work done in moving the charge. So here this E is 10 raised to power 4 Newton per Coulomb. The charge which is being moved is 2 millicoulomb, that is 2 into 10 to the power minus 3 coulomb. The coordinates of O are 0, 0, 0, that is origin you can say. Then A point is 1, minus 1, 0. B point is 2, 0, 0. And C point is 1, 1, 0. The charge is moving along this way and finally reaches to C. So, what is the plane of motion of the charge? So, if you see here, so this is 0, 0 is origin, no issue, and it is 1 and minus 1. So this is in advanced as the board, and then it is 2, 0, 0, and then it is 1, 1, 0. That means this is nothing but this board, the plane of the board. That means this is XY plane. So the first answer is the charge is moving in XY plane. And if you find the initial position of the charge, so R initial will become to 0I plus 0J plus 0K, and R final of the charge will become I plus J plus 0K. So second part, we find the work done in moving this charge from this point to this point. So we know work done is equals to F dot S or F dot delta R, you can say. The work done will be equal to force dot displacement, that is delta R. So here force is equals to Q into E. That means this is the magnitude of the charge force, that is equal to Q is 2 into 10 to the power minus 3 into the magnitude of E is 10 to the power 4, that is 2 and 20 Newton per coulomb, and it is directed along the x-axis as it is mentioned in the question itself, or showing this way. So we can write in vector notation, that is 20I plus 0J plus 0K, and delta R will be equal to R final minus R initial, that is I plus J plus 0K. Now the work done will be equal to F dot delta R, that is 20I plus 0J plus 0K dot delta R is I plus J plus 0K. These are the unit vectors. So that means this will be 20 joule. That is 20 joule. This into this is 20 and this further will become 0. So the answer is 20 joules, the second part. एक बार फिर से देखेंगे. Here this is the y-axis, this is the x-axis, and the electric field is directed towards the x-axis. ये parallel जा रहा है इधर. So E, the magnitude of the E is 10 to the power 4 Newton per coulomb. The charge 2 millicoulomb, that is 2 into 10 to the power minus 3 coulomb, is moving from O through A, B and till up to C. So this is moving with this path. The work done electric field is a conservative force field, and the work done doesn't depend on the way or the path but it depends only the initial and the final position. That way, first thing is the question is asking that in which plane this charge is moving. So the charge is moving in xy plane this way, because it's 0 0, it is 1 1 1 minus 1 0. So this is again on the plane, this plane xy plane, and this is 2 0 0 again on the x-axis, and this is again 1 1 0, that is again on the board. So this board is the xy plane. So the charge is moving on xy plane. So initial position of the charge is 0i plus 0j plus 0k, and the final position is c, that is 1 1 0, that is I plus 0k. So second part is how much work is, then calculate the amount of work done in moving this charge from O to C. So the work done is always equal to force dot displacement, F dot delta R. So F is equal to QE into E, because the charge is placed in an electric and uniform electric field. So the force on the charge is always QE. So that is QE, that is the magnitude 2 into 10 to the minus 3 into 10 to the power 4, that is 20 Newton per 20 Newton. That is not electric field, that is 20 Newton force. That will be the 20 Newton. Now F is equal to 20I plus 0j plus 0k, and delta R is R final minus R initial, that is I plus j plus 0k, that is minus minus will remain I plus j plus 0k itself, because the position of the C will be the delta R also. Now W equals to F dot delta R, so that is 20I plus 0j plus 0k dot I plus j plus 0k, and after making the dot product we will get the 20 joules.